Hello guys, so today I just want to show you how you can actually compile Qt, or better, not Qt itself, but Qt code in your regular makefile without passing from Qt Creator or qmake and stuff. There are several reasons why I actually needed to do so, and it was quite tricky. It took me a little bit to figure out. I think I had to bang my head against the wall for like 2 days before being able to do so, but eventually I did it. And the reason why for that is because I started doing my own project, which pure C++, not major external libraries. Then I started add TBB, and then CUDA for parallelism. And so I had my own makefile going, and then when my project was done, at least the core, I just wanted to add a UI in. And I didn't want to go and mess around trying to import my makefile in the one generated from qmake or this mess. So I just said, okay, I just want to compile manually Qt stuff with all my rest of the stuff. And that's how I actually achieved that. So this is actually the final result we have here. And you can see that if I run here the application, I could just do a make run where basically clean up, compile everything, and then run the application I just compiled. So you see just a basic window we have here. Okay, so now let's actually get rid of all that. I will try to go step by step with you generating this makefile rather than just explaining you line by line, because there are quite a few steps there. So I would just go from nothing to the final one. Of course I have already a copy of that makefile, so I will be copy pasting the stuff just to avoid typos, but you will see the step I take to reach that. Okay, so let me remove this stuff we don't need. Actually, let me run also make clean, which actually didn't work, I think. I'm just going to delete the stuff manually then. Yeah, my actual rule is wrong for the clean, but we're going to do that to fix that live. So no big deal. So let's get rid of that and let's get started. So first things you need is actually a UI file, okay? And the way you get one is using Qt Creator, just for generating one. So I didn't find a way to have just a designer running, so I actually had to create a new project. And so I create one and I actually store that inside my project in a junk folder, okay? Because that's stuff I don't want to use. I just want to generate .ui file, which is actually just an XML. So if you expect the XML basic, just an empty XML, it should probably work anyway. But that's just a simple way I get a form up and running. So you see this is a basic window. I can drop my stuff in here and there. So actually we just saved this, so we can get rid of that. We have our clean UI, which is actually inside here. So the first things I actually want to do is get this main window.ui outside this mess and copy that inside my UI folder. Okay, so every time I have the latest file ready to be worked on. Okay, so in order to do so, I'm going to create generic makefile rule. So I'm not going too much into detail for makefile because this is not a makefile tutorial. There are plenty of resources out there, you can check that. But basically this is a generic rule. This is our target, and so what we are going to work on, and those are our dependency. Okay, so basically this rule says every time you get this file that match this pattern, check that there is this dependency and do whatever it says here. Okay, so I need to know actually what file I want to generate, so what are my targets. I'm just declaring a variable called UI forms, because you can see from this rule, from a .ui files, I'm going to generate an identic file which is an header which has a prefix UI underscore. So if I have main window.ui, I just want a UI underscore main window.h to be used. Okay, so let's actually create some pony targets, for example whole, and later we're going also to use clean. So all will use the UI forms. Okay, so now should be able to trigger, but most likely doesn't know makefile where to find the .ui file, so we are going to add a search path to it, where basically we say, okay, you can find the old .ui file inside junk untitled, okay, which is the project we created. So let's see what happened now. If we run make, it's going to trigger all, and you can see it's actually run the copy correctly, and we have a clean file UI here. And this should work for any kind of UI files we add if we have many. Okay, so this is the first step. The second step, we need to use UIC, which is basically the UI compiler, to convert this UI file into a header file that we can use. Okay, so in order to do so, I'm going to declare a variable holding the UI compiler, which is UIC, and just create a variable UIC holding that, just because if in the future it will change, I can easily change that without messing around with my makefile. Now, the UIC is actually inside your installation folder for Qt. So in my case, I added a Qt path, installation path. You can see that here. Option opt qt 5.4 gcc 64 bin. So now it knows basically where to find the UIC compiler, sorry, the UIC program. And the only thing we need to do is basically tell him grab the UIC program, grabs the dependency and compiles that into include, sorry, inside include and the target. So let's actually see if that works. Hopefully it does. So if now we run make, here we go. We see we have a UI dot underscore main window.h generated. So you see it's not an XML file anymore like it was before, but it's a header that we can actually use. Okay. In order to use that, I already created a test window. You can see it imports that, and the test windows basically just implement the constructor here. So again, this is not Qt tutorial. I'm going to provide you with the code so you can study this base class, but this is basically the bare minimum class we can actually use. And actually here you can see the copy paste I created, that we have still the symbols for my personal project. But anyway, so that's the most basic things we have to do. So now basically what we want to do is just compile that all together. We have all the header, the CPP, and that's a regular GCC compiling thing. But we see is not that straightforward. So I'm just going to copy the GCC program and all the options. I use quite strict options, warning and stuff, just because I like it that way. So I have quite a bit of them, but I'm going to provide them so you the code so you can check all the flags I'm using. Okay, you actually need to use this flag FPIE because it's required from Qt. If you don't have that, it's going to complain. It's going to explicitly tell you, okay, use this flag. I actually had to add it. Okay. So now also I'm going to declare some other variables. So for example, the target, the name of my application, where I'm going to build. In my case, the build path is just build because I have a build folder here where basically I want to put all my stuff. And actually here we have quite a bit of junk. And I also are gonna add a source path, so basically where my CPP files are. Let me just make the clean function so we know that we clean ourselves. So I want to remove all the UI files, so all UI.ui, and also want to remove the UI, the header we actually generated manually, so I want to remove that. All the, sorry, is include UI.header. Okay, so, and of course I want to remove build all the O file, and also want to remove again build our target. Okay, so let's actually see if it works. So make clean. Okay, looks like we removed everything. Okay, so let's go back to actually compile our stuff all together. Okay, so let's create a variable for all our objects we actually want to compile, and actually I'm going to copy that. Oh, sorry, we also have a main CPP file actually created here, which is the most basic Qt application. Basically, we just create a Q application, the window is instanced, and we run it. Okay. Sorry, I'm kind of flying through that, but because that's not a Qt tutorial, so again, there are plenty of sources out there, and no need for me here and stay explaining every detail about Qt. Okay, so basically we want to generate a test window.h, sorry, .o, and a main.o. Okay. Uh, Now I'm going to generate another variable with a call fobjs, where basically I'm just going to replace each basically add a prefix to each object. Basically I'm adding the build path. Okay, so basically testwindow.o will become build path plus testwindow.o. So basically build slash testwindow.o. So basically when I'm going to link all together, they know where to find it, all this stuff. Okay. Now let's create a generic rule for compiling object, or the CPP actually, like that. So I'm going to use the CPP, the GGC command, the flags, the include path, which I didn't declare yet, and I'm going to compile the object and store and compile that as a build path target. Okay, so our target is the .o in the build path. So if I do so, I want to process my objs like that. Let's see what happened. It's going to complain cannot find stuff, but you see some stuff work. The CPP, sorry, the copy and the UIC work, but then it cannot find target for that because it doesn't know where to find the CPP. So we tell him all the CPP are inside source, and that should be enough. I'm not entirely sure. Let's actually see. This window.h, not such file or directory, so it doesn't know where to find the h file. Now it shouldn't. You should be able to do so. Let me check really quick. I cannot find this windows.h. Okay, because we need to actually add now the include path. So our first include path, we're just gonna say, hey man, all the includes are here. It's actually in the include folder. Okay, so now I start complaining, hey, I have no idea about what this Qt stuff is. So basically we need to start to add the Qt stuff. So the first thing to do is to add in the Qt path to the includes. So I do so. I use the iSystem flag rather than capitalized I, because on my system Qt was going to generate a big load of spam for conversion and stuff, which actually doesn't depend from me. I cannot do anything about it. So if I declare that I add the path as a system, make ZGC will see that as a system header, so it won't bother generating warning about it. But later I can try to remove that so you guys can see what I mean. So what happened now if you can find the include basically. You can actually compile successfully. But of course, we didn't generate an executable. We still need to link all the stuff together. Okay, so under our O, it means we generated all the O files. We actually want to link them together. So to do so, we're going to again call the GCC. We're going to pass. Actually, shouldn't be here, this one. So we're going to pass the path which we appended, we prefix the build path for our objects, and just say, okay, the output is going to be the build path plus our target. So in this case, it's going to be Qt test. So let's make a clean, let's make a make. So now, now we start having some problem here. Undefined reference to vtable. That's kind of cryptic, but I figure out what it meant. And basically, this problem here comes from the fact that we cannot just run Qt code like that, compile like that. From each class we basically create based on Qt, we need to generate some metadata, okay? And we need to use the mock command for that, which I believe is stands for metadata object compiler or something like that. I'm not entirely sure, I guessed. So basically we need to run the mock command on our header we generated, okay? Or in this case, actually, on our class, we subclass, so testwindow.h needs to be passed to the mock, which actually will generate a CPP file which needs to be compiled and linked together, which will generate all the metadata, and the vtable stuff will work. How do we do that? Well, let's try to make, actually, let's put in a rule to generate the mock file, okay? So the convention is we're going to generate a mock file plus the name of the CPP, okay? And the command is really simple, you see. You pass the header to the mock command and you say where you want it, okay? I'm going to put all the mock inside the build function because basically we are generating that on the fly. Sorry, in the build folder. So I don't want that in my source because this is basically being generated every time. So I just want to throw that in the build because it's part of the build basically. Instead an object for the build. That's why I put the output in the build path. So I'm going to create a variable for our mocks object that we want to generate like that. And as I do that, of course I want to pass those objects or those mocks to the all. So now when we should make, it doesn't have a rule for that, which basically we know that doesn't know where to find it, okay? So here is actually looking for the header to generate the mock, because the mock is generated from a header. You can see that from the rule. So we need to say that, hey, you can actually find the header file you're looking for in the include folder, okay? So we are setting again a search path. It's now run make. Everything kind of works because we still have the same problem here, but you can see a mock test window.cpp has been generated, and this file actually now needs to be compiled, okay? So I'm actually going to create a variable. Oh, we did a touch. I had this one open, so close that. I don't need to see that. So I'm going to generate another variable, create another variable which hold the object for that, and I'm going to again to use the same trick with the add prefix method to basically generate the same name but with the build path added, okay? So now I need to generate this .o file from the CPP. So again, I'm going to pass that to my all methods, so it's going to be compiled, and I want those to be linked together, so I need to pass the variable for the files mocks object to be linked. So now let me actually declare another pony target, which I usually call run, and the run target is usually in charge of cleaning, compile, and sorry, clean all, and then I also want to basically run the application we just generated. Okay, so let me copy the war rule here. So I call clean, I call all, and then I run the target in our build path. So let's see what happened now. Let's just do a make first to see if everything works. So we see it actually doesn't work because it doesn't know where to find the mock, sorry, the CPP file in this case. So we're going to say, okay, you can also find CPP file inside the build, and it's just going to pick up basically our mock file. So let's create a make. Alright, looks like everything is compiling, but there are a lot, basically, and I say a lot of missing reference. Let me just make clean, then I make again. Actually it looks like there's quite a bit of stuff missing. Let's see if I did something wrong. I'm actually not linking any library. Yep. So you see in the find reference, so that's the problem. You cannot find any library. So of course we need to add the library to Qt. So to do so, I'm going to create a library path which points to my Qt installation, and then I need to tell him which library basically I want to link to. So here I'm just the one I usually use the most. I don't need all of them in this case, but I just had this variable added, so I just basically keep copying and paste around, which is not that good, but eh. I just make stuff work, and I'm just going to pass at compile time the library path and all the libraries. Okay, so let's actually see now what happened if I do a make run. So I cleaned up everything, now it's compiling. So now we have different errors. So we get this missing reference to UC something, which I actually forgot the name of the library is looking for. So I don't know, actually it's here. So lib ecuuc. Okay, so basically it says, oh, Qt 5 core is actually needs this library and is not able to find it. And it's actually here, it's suggesting me to use an air path, or basically let me code a library path where to find uh, a specific library. So after a lot of searching, I found out this library being inside the Qt installation, which is fine, but not in the lib where I would expect it to be, is inside the Qt, actually the Qt creator folder. So what I did, I went there, and as the error suggested, I used the zzc command for the rpath to specify to look inside this folder, which is optional Qt tools, Qt creator lib, Qt creator. Okay, if I do so now, let's actually make run. It's compile finds, it can find the library, the reference, the missing reference, and you see we are up and running. Okay, but there is still one thing I didn't tell you. So it's up and running, it works because I had to set an environment variable. Let me show it to you, which is when I was running, it was complaining it could not find XCB or BC plugin for Qt. So I actually had to create a Qt plugin path variable and add the corresponding plugin path for my Qt installation. Once I did that, export the path. I do that in my bash profile with the other path. Everything went fine, and now Qt is up and running. Okay, so this was a quick way to show you how I actually was able to compile that. Probably is a bunch of work that you guys have simpler idea to do that. I'm open to suggestion. That's just the way I made it to work. So any feedback is more than welcome, and see ya in the next tutorial, guys. Bye.